Recording in progress.
I apparently sent the videos and everything to the wrong class. So again, I was after I went to the doctor last week, so I'll fix it when I get home. Chapter 3 is all done. We're gonna start chapter 4. Chapter 4 now we'll introduce probabilities and how it relates to our statistics. There are 4 sections here, but again, the concepts are pretty straightforward. Section 1 is called the basic concepts of probability. So what is probability? Probability is the chance that something will occur in the future. Remember, statistics is an analysis of what happened in the past. Probability is the guess of what's going to happen in the future. A perfect example, gaming. When you play blackjack at a casino or any game at a casino, you're playing probabilities that if you put this money in there now and make this bet, you'll win. That's all probabilities. So we have some terms we have to use. An event. Event is the occurrence. Whatever you're looking at happening. When you're betting on a craps table, the event is the roll of the die. All right, so the event is just that. Then we have what's called the sample event. The occurrence of an event in a controlled sample. Because remember, our entire purpose is we're trying to predict future occurrences. We're trying to determine what is this thing for the population of all of the gambles. And then we have sample space. The collection of all sample events. Three types of probabilities. One is called the relative frequency approximation. Of probability. The classical approach to probability. And the subjective approach to statistic or probability. The relative frequency one, because remember it's an approximation, is we look at occurrences, the frequency, a number of times an event occurs. So, number of times an event occurs and then we formulate an approximation approximate probability of that event. It's an approximation because we don't know the total number of possible outcomes. This classical approach is the one we always use. Finding the relationship between the number of times an event occurs divided by the total number of times that an event can occur. Find the relationship between the number of times an event occurs, a specific event occurs, divided by the total number of times that any event, not any, so any event can occur. And that's going to give us our formula. And the third one what does subjective mean? As opposed to objective. You heard these words before, but what do they mean? Subjective means it's subject to what you're experiencing. Objective is you're just using what you know. Subjectively, approximate the probability of an event occurring. we're going to be more focused on the classical definition of probability. The formula. Can anybody guess what it is? Yeah. Part over total times 100 is actually a percent. Because whenever you talk about probabilities, you talk about percent. More exactly, it's the number of times a specific event occurs divided by the total number of all possible events times 100. So what does that mean? For example, rolling one die and getting a 3. What's the probability of that? Mm-hmm. The way we write this is the probability of getting a 3. How many 3s are there on a die? 1. How many sides are there? 6. There's a die. It looks like this. Here's a question for you all. Have you ever noticed a die about where the dots are placed? So if you're looking at a die with one dot, this is on top of the dot, on top of the die. The number on the other side of the die from this one has 6 dots. The number on the other side, if the 2's facing up, the one on the other side will have 5. And if it's a 3 showing, the other side will have 4. Because they all have to equal 7 when you add them together. So that's how you can tell if a die is fair or not. It's one of the ways. Because if it's not fake, then the opposite sides of each die have to equal 7. Okay, how about example 2? The probability of rolling an even number. So the probability of rolling an even number How many even numbers are there on dice? We have one, 2, 3, 4, 5, 6. That's an even number. That's an even number. So you have 3 possible even numbers over 6, which is 1/2. Picking one card from a deck and getting a 10 of hearts. What's the probability of picking one card and getting a 10 of hearts? Are you familiar with cards? You never played any type of card games? Okay, so because actually this is where all probability restarted. It started in the casino because it all dealt with chance, and the casino want to know how can I make money? Because I don't want to have a game where I will lose more than they will. So they'll figure out mathematically does it work before they make the game public. In a deck of cards, there are 52 cards. In 4 suits. The suits are clubs, hearts, diamonds, and spades. Those are the 4 suits. The clubs and the spades are black cards. The hearts and diamonds are red. And all the cards all these suits go from 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the cards. And then we have a jack, a queen, a king, and an ace. So there's 13 of them. Each suit has 13 cards. So 13 times 4 is 52. And we had 52 cards in the deck. So the probability of getting a 10 of hearts is what? There's only 1 10 of hearts. There's one in there out of 52 cards. What's the probability of getting a red queen? Probably a red queen. There's only diamonds and hearts, which are red. So it's 2 over 52, which becomes 1 over 26. So always simplify your fractions when you can. How about the probability of getting a card less than 4? Nope. I don't know.
Oh, are we supposed to count all?
Ace is high. Ace is higher than king.
Ace is one.
That's why when you label, you start from two, go to king and ace. So the ace is the highest card in the deck. Yeah. So less than four could be what? 2 and 3. You have those two cards in each of the suits. How many suits are there?
4.
So 2 times 4. Is equal to 8 out of 52. So we divide it by 4, we get 2 over 13. And that's, now, what does it mean when I say 2 out of 13? Well, what it really means is if I picked 13 cards, 2 of them will be less than 4. Because then we have to talk about, okay, in one part, do we put the cards back when we draw the cards? If not, that changes the probabilities. That's called with and without replacement. We have to consider all that stuff too. So how about rolling 2 die and getting a 9? What's the probability?
Yeah. Well,
This would be dice.
how come?
Well, let's look at this. One die has how many sides? So 2 die also has 6. So what is 6 times 6? There are 36 possibilities here. What are the possibilities? So let's see. So whenever you deal with these probabilities, you have to first off determine how many possible outcomes are there. So the smallest you can get is a 2. Remember, you have 2 dice. It could be 1 and 1. So the smallest you can get is 2. So it could be 1 and 1. These are the rolls on a dice. So far, so good. What's the next highest? You get a 3. How can you roll that? A 1 and a 2 or a 2 and a 1? Remember, this is dice 1, this is dice 2. They're 2 separate independent events. Then we have a 4. How can you roll a 4? 1, 3, 2, 2, and 3, 1. The next one is a 5. It could be a 1 and a 4, 2 and a 3, 3 and a 2, 4 and a 1. You notice the pattern forming here? The left side, it increases, the right side decreases. So 1, 2, 3, 4, 4, 3, 2, 1. So the next one is a 6. So what is it going to start off with? 1, 5. Then it goes, this one increases, so it's 2, 4, 3, 3, 4, 2, 5, 1. The next is a 7. It could be 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. What's the next number? 8. How can you get an 8? Yeah, you can't do a 1 and 7. There's not 7. So you have to do 2 and 6, 3 and 5, 4 and 4, 5 and 3, 6 and 2. Next is 9. So that one's going to be a 3 and a 6, a 4 and a 5, 5, 4, 6, 3. Ten is 4 and a 6, 5 and a 5, 6 and a 4. 11 would be a 5 and a 6, 6 and a 5, and 12 would be a 6 and a 6. So there are your 36 possible outcomes with 2 dice being tossed. So again, the first thing you have to do whenever you deal with probability is find the total number of possible outcomes. So my question was, if you roll 2 dice, what's the probability of getting a 9? So the probability of getting a 9, 1, 2, 3, 4, out of 36, which is 2 out of 18, or 1 out of 9. So out of every 9 times you roll 2 dice, you should get one sum that equals 9. Will it always happen in those 9? No. How do we, but aren't the dice always going to give us 1/6 of a chance of every number? Yes, they will, because there's nothing controlling them. This is what we call the law of large numbers. The law of large numbers. What this thing says, if you repeatedly repeat the events, the outcomes will become apparent. What does that mean? If you repeatedly repeat the events, in other words, if I take one die and roll it, if I had one die and I rolled it 5 times, what would happen there? What could happen? They could all be one number. There could be 2 numbers spread out, or it could be 5 different numbers each time. But it's not for sure. But if I keep on repeating that die over and over and over and over and over, what's going to happen is after a very, very large number of rolls, your graph, your histogram, your frequency distribution will look like this. Because on a die, don't each of the numbers have the same probability of being rolled? So if that's the case, this is the probability of an event. This is the X, the probability of the event. They all have to have the same probability of occurring. Even though it doesn't happen in the first couple of times, it could happen after the million times, they'll all be the same. Which is one theory of gambling. According to the law of large numbers in gambling, here's a scenario. You want to go to Vegas, you have $1,000 you want to spend gambling, playing one game. Let's say blackjack. Would you get, probability wise, would you get more money betting it all on one hand and rolling it? Or would you get more money if you paid more hands? No. Because according to probability, what it says there is the probability of winning equals the probability of losing. 50-50, isn't it? So what happens in the long scheme of things is if you bet your money, the number of times you'd win would equal the number of times you lose. How much money did you gain there? Zero. You didn't gain anything. You broke even. Which in Vegas, if you could break even, walk away happy. You just had your weekend there and you got to experience the sensation of gambling, but you didn't lose anything. But what if I placed it all of it, 100% of it on one bet? What can happen there? I can either double my money, or I could lose it all. So in Vegas, to maximize your profit, bet one hand with all the money. Because if you play over the long scheme of things, you're going to be up and down, up and down, up and down, up and down. One of the strategies people have, let's say they bet $5 on one hand. If they win, great, they won $5. Then they bet the same $5 again. What happens if they lose? They're back to the bottom. But what they do, so if you bet the first $5 and you lose, bet $10 next time. Why is that? Because you'll get back your $5 plus the $5 you just bet. Because your bets are always going to be $5.
It's gonna remind you of the buy lottery tickets. They'll buy them, they'll lose, but then they'll have like a big win. When reality, you lost more than what you won.
Exactly right. Because all everybody remembers is that one big win I got.
Yeah,
I got a $3,000 jackpot. Yeah, but you bet $7,000. But people don't remember that.
yeah.
And so that's why whenever I go to Vegas, I always start off with one table, whatever I start off with, is $100 in chips. Anything I make above that, I put it in my pocket. Out of sight, out of mind. I forget it's there. So that way I'm always playing with $100. Once that $100 is gone, I leave. Or if I double that, if it becomes $200, which I won't because I always put it in my pocket. But if I ever forget and it gets 200, I quit.
You know, those people,
I know.
they win and they're.
I'll win again, I'll win again, win again. Exactly. And that's why gambling is very dangerous. And if you're going to gamble, make sure you can lose the money. Don't ever gamble something you can't lose.
They gamble with it.
And that's what it's called markers. When you go to a casino, if you don't have any money, you get a marker, which is the house giving you credit that you have to pay back. And sometimes people put their cars, they put their jewelry, they put their house, they'll put lots of other things as collateral. And then they lose, they go home, say, listen, we don't have a house anymore. It happens all the time. Which is then yeah, that's the stinky part of gambling, because it becomes an addiction. So, okay, now if I lose the next one, I bet 20. Because my goal is, if I ever win, I will win $5. Because this $20 made up for the 15 I lost earlier. So I only get $5. If I lose there, then I go up to 40. Think about it. $40. You have 20 plus 10 is 30, 35. Again, the difference is going to be 5. So yes, you win a big one. You hit $40. You get your $40 back. No, you really only got $5 back because you lost 35 earlier. But again, that gives you the thrill of gambling. If you have the thrill of gambling, if you want to do that thrill, and then, but you won't be out more than $5 at the end of the day. Unless you keep on losing. Because if you look at how fast this adds up, imagine putting $1,280 down on one bet just to get back $5. Yeah, but this is extreme if you lose that many hands. Yeah, you have to have a limit. I can't, anything after 40, I don't want to bet anymore. So, because if you lose 40 in this bet, you've actually lost how much money? 60, 70, you've actually lost $75 by that time. So this is the stuff, this is how come, if you understand probability, you'll be not a good gambler, you'll be a safe gambler. You won't go bankrupt. You'll have, you know your limits. Yeah, well, that's another thing. If you count cards, you're not counting the numbers. You're saying it's either +1 or -1 on the card counting. And
You can do that.
well, no, they can't get, but it's not illegal.
Well, they don't value
But then again, that's because they also have each poker hand, each poker deck has 7 decks in one shoe. A shoe is the thing that holds the cards. That long thing. There's 7 decks in there. So 7 times 52, 364 cards. But you don't play all 364 cards. Let's just say these are the 364 cards. They let somebody put a card, and that person puts a card there. So that means this stuff, these cards now go in the back, and the dealer puts the card somewhere. So you don't know how many cards are played here. These are how much cards are being played. Because once you get to this yellow card, that shoe is finished, that's reshuffle. So it's this unknown. The larger that number is, the less you know. Because this could be all your aces in here, or it could be all in here. So that's really trying to do to make it more difficult for you. That's why, and again, if you're counting cards, you have to be zoned in 100%. Because any type of miscalculation on your part, you just hurt yourself in the long run.
I did not know that gambling had this much into it.
Oh, in a casino, they are more accurate. When you go to what's called a sports book, and you can watch the games, basketball, baseball, football, soccer, track, you name it, horse racing, you can bet on it. They know the sport so well that they make those odds So they'll win more times than not. The only time the house ever loses is if something weird happens. Some long shot, like the person who's favored to win, let's say a tennis match, sprains an ankle. And they have to forfeit. And so they factor that in. It's amazing how much they know. They know more, they can predict when you're gonna die pretty much. And so, yeah, so Vegas has a bunch of brainiacs there, the best mathematicians, the best statisticians in the world. I mean, people who do this for a living. Vegas is a town that losers built. Losers. Think about that. How do they get the money? People who lose gambling. So all that money built, all the people who lose make these hotels bigger. So it's a town that losers build. Which again, well, what you think about it, it's very funny. It's true. It's not that if the winners, they take the money and run. But again, you actually only won maybe a small percent of what the difference is. Okay, now let's look at the other side of this. A complement in probability. It's noted by with a bar on top. Not X, because remember X bar is mean. An event is classified as a capital letter A, B, C, D. The complement to that event is a bar. I forgot to tell you earlier, when we talk about probability, what is the range of probabilities? Yes. Probabilities has to go from 0% chance to 100%. You cannot have more than 100%, and you can't have a negative probability. Right? True? Everything else has to happen between these two numbers. So a probability of an event has to be between those two. And they can be equal to the ends. Now, converting it from percent to decimal, what this means, the percent symbol simply means 1/100. So this one, 1/100. I convert the percent symbols into 1/100. 0 divided by 100 is 0. 100 divided by 100 is 1. So here is your range of probabilities. Your probability number cannot be greater than 1, cannot be less than 0. It's otherwise a decimal or a fraction. Well, it also makes sense. Just think about it. With our definition, the top number is the number of times an event occurs. over total number of possible event outcomes. Event outcomes. So which number is larger? The number of events occurring or the total number of possible outcomes? The bottom one, yeah, because this one includes everything that you're looking for and everything you're not looking for. For example, the roll of a die. There are 6 sides to a die, but you only want one side. So since the bottom's always larger, it's going to be less than 1. With that, since our probabilities have to be between these, let's make it A, I'll make it probability of A the highest it can be is 1, right? So the probability, the highest it can be is 1. What does that mean? If the probability of A equals 1, what does that mean?
That is even you to use it.
It's 100% of the time. That means the outcomes equal the total number of possibilities. Is that always going to happen? No. P of A are the desired outcomes. Then the opposite of desired is not desired outcomes. We represent that by the bar symbol on top. So the top one is what we want over, and this one is don't want. Which means the probability of A plus the probability of not A is equal to 1. Why is this important? Because sometimes it may be easier to find out what we don't want than what we do want. Because if algebraically, if I subtract this from both sides, then I get that. So if I can find out what I don't want, it's that if I subtract it from 1, then I get what I'm looking for. So it may be easier to find out what you don't want and then subtract it from 1. Case in point. Remember the 2 dice being tossed? Two dice are tossed. Find the probability of getting a number less than less than or equal to 10. You have two dice being tossed. Find the probability of getting a number with one roll of the die, of the two dice, that they equal 10 or less than 10. Don't go out counting all that stuff. Because remember what it looks like. Remember what it looked like. All these, right? So we want anything from a 10 or below. We want all these, right? Then let's look at what we don't want. What do we not want? So this is, we're looking for 10 or less than or equal to 10. What do we not want? We don't want 11 and 12. So we don't want these two, right? Well, how many of them are there? There's 3 of those. There's 3 out of 36. So what we're looking for is the A, 1 minus what we don't want. So 1 minus 3 over 36. Common denominator, 36 over 36 minus 3 over 36. So 36 minus 3, which equals what? So if you're going to count them all, you're going to count 33 of them. All the 10s, 9s, 8, all the way down to 2. They both have 3 in common. So it's 11 out of 12. It was a lot faster finding what we don't want and subtracting it from 1 than looking for what we do want. So there's an example for that. So far, so good? Yeah, see, we could do the second section, multiplication and addition of probabilities. Well, my teeth are killing me. No, oh, they'll do that tomorrow. We're gonna finish up the chapter tomorrow because they all go together after that. Yeah, so for addition, we've talked about it a little bit today about adding the probabilities. When you add probabilities, you have to make sure of a couple of things. One is you have to know what the possible outcomes are. 2, you have to know what the events are you're looking for, and you have to combine them. But there's one problem. Can you count too many of them? What we're gonna do tomorrow is the addition symbol is used for whenever you use the word or. Whenever you use the multiplication symbol, we use the word and. So the possibility of A or B as opposed to the probability of A and B. Because and combines the two. It's this and this. Where do they overlap? Or it takes this and puts them together. Wait, what? Yes. But here's the problem. What's the probability of getting a red card or a 10?
Yeah, all of it. Just 36. 32, right?
Nope.
36. So he,
Half of 52 is 26. Yeah, because these are all the hearts and diamonds. How many 10s are there? There's a 10 of hearts. There's a 10 of diamonds.
Oh.
There's a 10 of spades. And a 10 of clubs. So there's 13 of these, 13 of these. So it's 26 plus 4 is 30. But that's wrong. Because inside here, this one has a 10 of hearts and this one has a 10. So these are counted twice. So we only have 28.
But that's meant to trick you, right?
It's meant to keep you from being tricked. Because whenever you're adding to probabilities, you have to make sure there's no overlapping. They have to be what's called independent, not mutually exclusive. Whereas they can't have anything in common. That's what we have to be very careful about. When we multiply, there are two things on multiplication. That's just for addition. In multiplication, we have to look at 1. Is it just the multiplication of each separate probabilities, or is it conditional? Whenever you multiply probability of A and B equals the probability of A times the probability of B. You can say that if the two events have nothing to do with each other, if they're mutually exclusive or independent of each other. But what if event A has to happen before event B? In other words, okay, I'm drawing 2 cards from a deck. The probability of a king of hearts and the probability of a spade. Two cards are being drawn. What's the probability? The first one's a king of hearts and the second one is a spade. So this one is conditional on this one. Because if I don't get a king of hearts in the first one, I'm done. I don't have to do it anymore. So what's the probability of getting a king of hearts? 1 out of, no, 52, the deck of cards. Don't get the coins mixed up. That's the first one. It was done. So what's the probability of the second one? Getting a spade. 13 out of 52, which is 1/4. Now you multiply them, which is 1/208. So what does that mean? Well, if I drew 2 cards 208 times, 208 times, I would get a king of hearts first on the first one and then a spade on the second. If I do it 208 times. So you see how difficult it becomes now. But yeah, we'll talk about those tomorrow. Because now we'll talk about with or without replacement. Because what is, if you don't put the card back, what happens to the probability of the second event? Yeah, the first probability is 1/52, right? I keep the card. Now it's probability of 1/51. So that's what we'll look at tomorrow. Okay, thank you, everyone. And I will get those videos to you ASAP.